Let's pick up our presentation here, Cybersecurity Basics. Let's pick that presentation up from where we left off. We were talking about how much your code matters. It's central, obviously, to secure systems. And building that code out, become familiar with that OWASP Top 10. That's something that might enlighten you, and you might find something out there that you hadn't thought about as a way that your application could be attacked. Well, let's talk also then about protecting the core. We have to protect data when it's at rest and when it's in transit. When it's at rest, we're talking about data that is stored on disk. When it's not being used, it's stored on disk, and we retrieve it through a database connection, web service, something like that. That data is sitting somewhere on a server. So that's something we have to protect when that data is at rest, when it's just sitting there on the server. We also have to protect it when it's in transit, when it's being transmitted from the server to the client, to the person that's requesting it, however that may be, whether that's an app, whether that's a website, whether that's a different program entirely, whether it's being consumed by another system. We have to protect that data while it's in transit. A few different ways that we have to do that, several ways that we have to do that. A couple that we'll talk about here, tokenization and data loss prevention. We'll talk about that here in the next slide. And then also coming up a little bit later, we'll talk about classification and lifecycle policies. So tokenization, it's a technique that we would use to, well, not really encrypt, right? We're just obfuscating or substituting in other numbers, because there's really nothing meaningful in that data, in that token that we're creating. It's a random string of characters. There's really nothing. If it's intercepted or if it's stolen while it's in transit, if they get access to the entire database table that has that stuff in it, it doesn't really matter. We're storing the actual data in a secure database. Might call that a token vault. It can only be retrieved with proper access. We would lock that database server down. We would lock access to that database server down. Payment systems will use that. Healthcare records, educational systems can use that as well. It reduces risk of exposure. It separates that front end from the back end, and even a more secure core layer where we have the real data. So an example here, storing a credit card number, all 4 ones. By the way, if you ever need to use a test number, like you want to test if credit card functionality is working, it's right there, 4 followed by a whole bunch of 1s. That's like a test Visa number, not a real credit card. We might store that then as just a random set of digits. You see there. Real number is, of course, that 4111, and so on, is kept on a more secure server. So then looking at a higher level, we're talking about the policies and the tools and the processes that we have that are designed to prevent the unauthorized access, prevent that unauthorized sharing or leakage of sensitive data. We refer to that as data loss prevention. A DLP system would monitor how data is used and how it's moved both inside and outside of an organization. Inside, meaning moving from server to server, maybe moving from server to a customer service rep to their computer. How are we getting that data back there and making sure that that customer service rep doesn't steal the data that they're looking at? And there's limited things that we can do, right? If they could take a picture of the screen with their phone and see things there. That's a means that they could steal individual customer information. They could be writing it down on a piece of paper as they're taking that information from a customer over the phone, and so on. So we have to think about that, but there's only so much that we can do. Maybe locking down USB ports so the customer service rep couldn't put a USB drive in and steal everything off of that USB drive, transfer large amounts of data from that USB drive. If we find that there's a correlation that might come back, if an individual customer service rep is stealing data, we might find there's a correlation. Well, those data elements that got stolen all trace back to someone that had interactions with these customers. Of course, that then only means is something that we can trace if we're able to trace it, if that customer service rep is keeping notes on file of their interactions with customers. So there are multiple ways around it. But again, we can't fix everything. We talked about how to mitigate risks last time, and we talked about risk and calculating likelihood and impact and so on. Well, the impact of a customer service rep with a USB drive taking all of your data versus taking some random caller information that they might talk to that caller and copy that down, one or two of those. Not that it's not serious. If you have your information stolen, of course, that's very serious. There's no real difference between you having your information stolen individually and it being included in a huge breach, other than the likelihood is that if someone steals or targets you, they're going to use that information versus it just being included in a data dump. But anyway, on this slide, back to the slide, so restricting copy or paste, copy and paste and file transfers, those types of things, that's what I've been sort of talking about here while the slide's been up. We can also flag or encrypt sensitive information before it leaves the network. So watching when people access certain data. And those data loss prevention solutions will often use content inspection. If something looks like a social security number or looks like a credit card number or has certain keywords in it, then that DLP system might send an alert based off of that. When we're thinking also about data security, we're thinking it around that human layer. We've been talking about it for a little bit. Social engineering and phishing, I talked about in the previous lecture, award-winning previous lecture. If you could hear it, I understand there were some audio issues with that. Hopefully this one is louder. Just what you always wanted. Social engineering and phishing, though, we talked about phishing a little bit, sending emails to an HR person or a payroll person, and they're going to click on them, and they're going to, whatever that phishing attack does, then will be launched because of that phishing email. But social engineering is well, sort of, phishing is a type of social engineering, right? If I call you, and AI is going to be great, already being used for this. You can make a different voice with AI, and if I have enough samples of data, well, maybe I can make myself sound like just about anyone, and then call you and socially engineer you into giving me or sending me some confidential information. And so social engineering refers to that type of attack where I get in contact with you, make you think that you're doing the right thing by helping me, and in reality, then I would be posing as an attacker, and then be able to get that information from you. The way around that is often security awareness training, but we have to be aware of security theater, checkbox compliance, things that are meaningless, that look like security but really aren't security. They're really not protecting things. Checkbox compliance is a term that we would use for, well, we've all done this training, and so everything must be okay, right? We don't need to monitor email. We don't need to monitor for phishing because everyone had the security awareness training, right? Well, yeah, okay, not really though. We know from a technical side that taking the training and actually listening to the training or responding to the training and using that training are two different things. So we still need to be implementing all of these other things. I would argue that because we've done security awareness training, we shouldn't have MFA because we shouldn't need it, right? Or do we not need the security awareness training? One of those two things, maybe, right? So MFA, multi-factor authentication, is there as well as something that we can think about. But as we're talking about that security awareness training, and we're talking about the protections that we have on a network and that we can add to a network, we should really have that distinction and make that distinction clear between measures that are preventive versus detective versus corrective. A preventive measure is meant to stop an attack. Think about a firewall or an ACL, an access control list. That's a preventive security measure. A firewall stops people from getting access to things that are behind the firewall. and we'll ignore weird attacks that they would be able to get through the firewall. Let's ignore that. It happens, but we'll ignore it. Firewalls, though, would be a preventive measure. They're preventing people from getting into the network. A detective activity is something that we're doing to detect an attack. Intrusion Detection System, or IDS, is there logging, just keeping track of what's happening. If we're logging all of the authentication attempts on the network, we can spot that activity. We can view what's happening, see if there are certain IP addresses that are constantly attacking us or constantly trying to log in. We find that through that detective security measure. Corrective security measures, things that we do to mitigate damage. So if we have a backup, being able to restore that backup after we've been attacked, we're mitigating the damage. Being able to turn off sections of the network, being able to block IPs is a corrective measure. If a certain number of authentication attempts occur from a certain IP address and they fail, well, let's block that IP for 15 minutes or 30 minutes or something like that. That's a corrective action. Combines detective and corrective, but really it's corrective because we're blocking that IP address. All of this ties to a zero trust architecture, a term that you might hear. In a zero trust architecture, we have to verify every request, even if it's from internal users. We have to make sure that the request that's currently being served or serviced is legitimate and that we should be servicing that request. So trust but verify is how a data security manager once put that to me when I did data security administration for a company for a while. Trust but verify, and making sure that something is exactly what they represent it to be. Checking that access. And MFA is a good example of zero trust architecture in action, or how we might implement that. Think about MFA, meaning something you know, which is your username and your password. Well, the username is really considered public information. The password is the something you know. MFA then adds something you have, that token, the app on your phone or the little hardware token that goes with it that displays the random characters every 60 seconds, rotates over. Something you know and something you have. Just because you have your password, someone else could guess your password, right? They know your username, that's public information. Your password, then they can guess. And so how do we trust that that authentication request that's suddenly coming from a new IP in a far, far away land is actually you? Well, we can't. So that's why we go to the next level with MFA. And then we have it's something that you have, right? Because now we're relatively sure that even if it is from a far, far away land, a different IP address than you normally log in from, we have the username and the password, but we also have the extra step, the MFA, the something that you have. And that adds that extra security blanket, if you will, that extra knowledge for us that we have been able to verify that you are who you say you are. Within a zero trust architecture, we're assuming a breach or attack, we're limiting access by default. Rather than having everything wide open, we're assuming that everything should be completely closed and only add access when the access is needed. Segmentation is also on this slide. Network segmentation, or segmenting interests within a network. A very common way or easy way to do that is just keep client things away from server things, to put it crudely. At UW on campus, you would find or many enterprises, same thing. You would find the wireless network to be segmented or separated from the main network, or the wired network, or the servers, certainly. And that's a very common thing. If someone from sitting outside the building can break into the wireless network, which they could, then they won't get very far because they can only access things on that wireless network, which would not include anything that's segmented off away somewhere else. And continuous monitoring is another thing that we would do in a zero trust architecture. Assuming that we're going to monitor things continuously, we need to know when those anomalies are there, when things don't look like they normally do. Maybe that's suddenly our normal network traffic is 100 meg per second outbound, and suddenly it's been 500 meg per second outbound for the last 20 or 30 minutes. Does someone have a big torrent going, or is there something else going on? Where is that traffic coming from? And we need to know those types of things. That's what continuous monitoring gets us, irregardless of a zero trust architecture, but that's definitely something we would implement in a zero trust architecture. Some of the common attacks that we'll run into today, misconfigurations are very common, whether that's in the cloud or not, but cloud is I won't say very easy to misconfigure. You now need to really do things in order to misconfigure a cloud implementation, but it still can be done. A misconfiguration, you have to actively try to do that. In the old days of the cloud, which is scary to say, but in the older days of the cloud, there were things that were a little bit more wide open by default. Those have largely changed now, but misconfigurations can still happen. And supply chain attacks are a thing as well. We'll talk about supply chain attacks in the next slide. But again, we've also talked about the human element, social engineering. That's a very common attack that you'll have now. Third-party integration, so things that we call out through an API, an application programming interface, things that we call out through an API might be abused. If someone can find that API endpoint, we don't have that protected as good as we thought we did. Well, then an attacker can go right after that API level and attack that way, maybe cause a denial of service or maybe cause it to behave in an unexpected way. Session hijacking, compromised credentials are a couple of different common attacks that we would encounter today as well. Stealing someone's username and password, or grabbing the session cookie if they're on a Wi-Fi network and you have the ability to listen to that traffic. Maybe it's not over HTTPS on a Wi-Fi network, and suddenly you're able to hijack that session. Shouldn't happen that often, but still can happen today. So supply chain attacks, we're going to expand on those here a little bit. Compromising software updates or dependencies. So let's talk about what that means. If I get access, let's say I get access to push code into your GitHub repository, and that code is then automatically built and deployed out to the users. If I can add a couple of lines of code, I can make everything be sent to a server of my choice. So I can make it, when the payment transaction goes through, I add a little bit of code, and now suddenly everyone installs that software because they think it's normal, right? I got into that supply chain and infected that software during the build process. That's a supply chain attack. SolarWinds, you could look that breach up. And I've included a link to that breach here in the slide as well. But SolarWinds is an example of a very serious supply chain attack based on what SolarWinds does and the access that it has on networks. That's a good example that we have. Something we've talked about a little bit, but I'm going to add some terminology to it, is phishing and social engineering. Again, it's one of the most common ways that people will get into a network, but I want to introduce the concept of business email compromise, or BEC. You'll hear that term sometimes. Think then also in terms of the differentiation between spear phishing and mass phishing. Mass phishing is if I send emails to everyone. I figure out the pattern of email addresses for your organization, and I send an email to everyone in hopes that someone, if I send 1,000 of them, maybe one person will click on it, and that's all I need. Versus spear phishing, which is more targeted. I send something that really looks legitimate with your name in it, and it's related to your job, and that makes you more likely to click on it. That's a spear phishing example. And voice phishing is the final thing on this slide. That's, again, I talked about that a little bit related to social engineering before, But that really then relates to deepfakes and AI in attacks. If we can fake voice and fake video for scams, we can make people do things, and that's going to be real and going to be more and more real as we go. And as people learn relationships between individuals, they'll be able to make AI sounding audio real time, and we can do it now. There's millions of examples of that on YouTube of people doing those exact same things, using voice changers in real time. And you can then see how that happens and how someone might be taken advantage of with that. And then also the use of AI to write really good phishing emails, really convincing phishing emails that might not have the normal grammar things that we look for and normal signals that we might look for in a phishing email might not be there, because generative AI is going to help write those phishing emails, and it's going to make it much more challenging to detect phishing emails and then to try to attribute that to a certain individual or trace that back. All of that then ties into incident response planning. How do we handle the incidents that we have that are occurring? And several steps within that preparation. How do we prepare for it? Well, we make a plan. That's the key of planning, right? But we then have to detect things. So we have to make sure that we're listening in the right places on the network and we're listening for the right things. Once something happens, then we need to make sure that we're containing that. We don't allow it everywhere on the network. We talked already about segmentation. And then eradicating it, restoring from backup, re-imaging a server, those types of things. And then recovering from it, making sure it doesn't happen again. Within an incident response plan, you'll usually have clear roles. You'll usually have a playbook. So if this happens, you just follow the playbook. You don't have to then think about what you should be doing because the playbook says to do it. It works great when the playbook works. It doesn't work great when things go outside of the playbook or when there are multiple attacks occurring at once that are outside of the playbook. But it's also important then after something happens to do post-incident review and lessons learned, because you can improve for next time. Having helped recover from several incidents, security incidents in my career, definitely lessons learned. We won't do that. We won't do it exactly like that again. Of course, by then the attackers have moved on and they're using a different method to attack. But we're still guarded against that type of attack. What we've seen in the past, we're guarded against. Sort of like an antivirus would do, where it has signatures of viruses that it's seen before. Well, those aren't going to be the way that they're going to be used in the future. Let's talk then about the NIST Incident Response Lifecycle, the National Institute of Standards and Technology. They've created a step-by-step model that's widely used for to be able to respond to incidents. And it helps to provide those processes if we don't even know where to start, right? We can also integrate it with detection tools and our workflows for compliance, making sure that we're ready for an incident response. A lot of organizations will set up a security operations center, an SOC. And so an SOC will be a 24/7 monitoring triage response center. A lot of places can't be staffed 24/7, 24 hours a day, 7 days a week. So we will set up smart alerting. Analysts will use various tools. You can see them. I have included links to an SEIM and also SOAR included on this slide. Various tools that will be used by analysts within the SOC, within the SOC. But you have to be aware of challenges around operating a security operations center. One of the primary ones is alert fatigue, just getting the number of alerts. And I talked about this in the first video, where the sheer number of drive-by login attempts on a given day on a server is too much to respond to. You can't respond to each and every one of them. You have to look for patterns, and that's where AI can help with that. There's also a talent shortage. We can hire people, but hiring people that have the knowledge and experience to work in a SOC is challenging, definitely challenging. And it can be complex. Sometimes you guess wrong as to whether something is an attack, and you might send out or escalate something that's not really an attack. It does happen. But AI is going to be crucial for a modern operations center related to cybersecurity. Log analysis correlation using machine learning is something that's going to be incredibly vital for an SOC. And we can use threat detection, anomaly, behavior models, those types of things AI is good at. Let the computer do the work. AI is really good at those types of things. And then helping with and learning from the automated triage and prioritization of the attacks, of the alerts within an operations center as well. So when we're looking at AI overall, the speed and scalability of AI for cybersecurity is beyond what we can do individually or collectively. AI is just better at it because it is able to connect the dots in ways that humans might not be able to. And so it helps to reduce that alert fatigue and the manual triage that we need to do. But it's important that AI is really just a way to augment, not replace security analysts. We still need to look at it. And of course, AI is only as good as what it knows and what we've taught it, which leads us into the types of AI that we use in cybersecurity. Supervised learning, known threats, things that are going to be classified as spam, for example. So supervised learning classifies the known threats. Whereas unsupervised learning is detecting unknown anomalies, things that we haven't seen before and that we might not have seen, but AI is able to connect those through some unsupervised learning. And then reinforcement learning adapts in real time. So an automated defense system that adapts in real time to what's happening on the network. And we talked a little bit about anomaly detection. I also want to just formalize that here on a slide. Anomaly detection, I've used the term before, and I don't think I had this in the first lecture. But anomaly detection, easy for me to say, is a way to detect deviations from normal behavior, things that don't look normal on the network. We shouldn't be getting all of this data. I used that example before. All of this data shouldn't be outbound on the network for this long. Something must be happening. And when we're using AI for that, we're going to be using isolation force clusters, autoencoders. Clustering is a technique that we'll use for that. Definitely helps for that insider threat. Again, exfiltrating data and also lateral movement. We shouldn't be getting a port scan from that server to internal of the network. Why is there suddenly an attempt to access that port from that server? Not to that server, but from that server. That server shouldn't be accessing anything external, so we're going to firewall it off, but then it's also starting to scan internally. So that's an example of an anomaly that we would want to look at. AI is also good for email security. Natural language processing can help us with phishing detection. As AI gets better at writing phishing emails, that natural language processing will also need to improve, but pattern recognition for credential harvesting. If someone's trying to break in and they're using the same types of patterns, we would be able to spot that with AI, or AI would help us to do that much easier than us trying to go through a log file of 1 million lines or so and spot that pattern. I'm laughing because I've done it, and you tend to miss things after a while. And then behavioral baselines for impersonation attempts, talking about that social engineering. Is this normal for this person to call me and ask me for that certain information, some confidential information? You'll know it's not normal, so let me call them back. That's the easiest way. And if you think about that, somebody calling and acting or posing as your bank, and they suddenly need to verify your username and password because of whatever reason, well, the easiest way to handle that, even if the caller ID says it's your bank, the easiest way to handle that is to say, I'm sorry, I'll call you back, and then hang up the phone and look up the number to your bank. I don't remember the number to my bank. I would need to look that up. And so I would look up the number to the bank and call it and say, did you just call me? And chances are they didn't. So that's an easy way around it, but AI will help with that type of thing. and alert us as that impersonation attempt is happening. Network traffic analysis, another way to look at anomalies that are happening on there, but we can be detecting. I talked about data exfiltration, someone stealing a whole bunch of data. Port scanning I've talked about as well, but beyond that, some of the flow-based features within there, suddenly the protocol is being violated. And IDS, an intrusion detection system, will help with that as well, but we're hoping that AI and looking to AI to help with those types of things that are a little bit more complex and nuanced. A human can do it, absolutely can do it, but it takes time. And we have a limited amount of time that we can be looking at as humans at this information. So AI can help and say, help us alert to something that might look abnormal with packet timing or with a protocol thing. And also, by the way, that IP address also has this other issue. So that's where AI is going to really help with those types of things. And then, of course, we have malware detection. For AI will help with malware detection. Just looking at file signatures and structure, I talked about in the first lecture about file signatures and hashing for files. That's static analysis. We might refer to that as static analysis. AI can help with that. And dynamic analysis also, AI can stand up a sandbox environment and test that application to see what behavior it has, see what it's trying to do from a network perspective, but do it safely in a sandbox environment. And then AI can also reduce false positives in antivirus systems as well. Behavioral analytics are used and helpful from AI as well, analyzing those user behavior patterns. It's things as nuanced as typing speed or the location. I referred to that a little bit before, someone logging in from a land far, far away. Well, that's not normal. That's not a normal behavior pattern that we have for this person. And so that's a data point. It doesn't necessarily mean we need to block that authentication attempt, but it certainly needs to be a data point that we would use to say, well, this person's not normally logged in. They just logged in earlier today from what we would consider to be their normal home IP address, and now suddenly they're logging in from halfway across the world. Well, chances are they didn't make it between home and halfway across the world in an hour and a half. And so now we can look at that and say that's not normal, and at least temporarily either block the IP or block that account, or both, I guess we could do as well. AI can help with threat intelligence, help to analyze, correlate things at scale, and that's often what we need to do when we're dealing with large amounts of traffic. And AI can help identify those indicators of compromise, or IOCs. And could also help us then to prioritize the data that we have with some context and help us to prioritize what's most important. So using that example of logging in, well, we just received a login attempt from a different country. Oh, by the way, AI pulled up that this person logged in earlier today from their home a few miles away. So that's something AI can help us to look at, connect the dots, if you will, within that. AI can also help with incident response automation. Those SOAR platforms we talked about before leverage AI for decision support and can be used to auto-block or contain the incidents as they occur to prevent further damage, to mitigate that damage. And then AI can also help escalate based on what it would consider to be a severity score for that. There are some challenges, though, with AI that can occur, limitations of AI. Our adversaries, the people that are attacking us, are going to have those models as well, and they're going to be able to do the same things that we are. They're also possibly going to be able to poison the models that we're using. In other words, hide what our model might normally be considered to be an attack behavior. If an attacker is able to poison the model, well, suddenly they know that they can make their attack or hide their attack on something that AI won't detect. So it's not going to eventually it will, but certainly not right now, replace everything that we would find in a defense in depth type of scenario. AI can also, until it's trained, have a lot of false positives, and we can get that same alert fatigue. We just have to keep training the AI to get better and better, but we risk overtraining it and missing out on an alert that we should have received. And one of the fundamental issues that we have, and this is true of AI, we have to have high quality labeled training data. We've got lots of data. We have lots of log files in cybersecurity. We have to label those things and help AI learn what's good and what's bad within that data. This is a normal pattern. This is not a normal pattern. We would want to flag it. This is not a normal pattern, but it's not serious. But you want to keep it as a data point. We have to figure out how to train AI, and we're working on it, of course, industry, and we have a lot of that already, but there's always a need for that labeled training data, especially for your individual network. We know certain IPs in certain countries of the world, the IPs coming from there look like attacks often. We know that already. But what does it look like for our network? We might need to interact with that. Our organization might need to do business with people in that country, so we can't just simply block all the IPs. That's just not how it's going to work. So there are some limitations. They're being overcome every day, of course, and we're getting further along in overcoming those challenges of AI and cybersecurity. So I hope you enjoyed this second video. I hope the volume was better. Look for your feedback on that. And this additional second lecture on an intro to cybersecurity. Thank you for watching.